Hello everyone. So in this segment we are going to learn about predicate logic. In our earlier of this course we learned about statement, mathematical statement, right? So a mathematical statement is a English sentence where we can evaluate that sentence only either using a true or false. Now we saw a couple of example like is a English sentence with a variable. Say for example x is larger than 10, something like that, or we can write that x is larger than 10. Now this statement, I mean this sentence here, we are saying that x is larger than 10 where we do not have any idea what is the value of x. Okay, so we cannot evaluate this one with either true or false, so we said that that's a invalid statement. Okay, or that's not a mathematical statement. All right, so now the thing is that now the idea is that if we have knowledge about this, about the value of the variable, then we can actually make a decision whether this statement, whether we can evaluate this one with either a true or false. Okay, now in that case actually we are going to use a concept, predicate logic. So this is the case where we are going to need a predicate logic. Each predicate logic include three of the ingredients. Okay, each predicate logic has three ingredients. Predicate logic has variable. Predicate, variable means x, y, z. Okay, they will be the subject of the statement. Predicate means a property of the variable. Okay, and quantifier, we're going to talk about that in the next topic, but the mandatory ingredients of a predicate logic is that variable and a property. Now instead of just writing x greater than 10, we can actually write a predicate logic something like that. So here that's a predicate logic. We are saying that that's a predicate, and the predicate, the subject of the predicate is a variable x such that x greater than 10. Okay, or we sometime also it read as like that, px is the predicate, b x greater than 10. Okay, so a predicate represents a property of a property that a value can have. Okay, for example here the property of x is x greater than 10. All right, all right, or we can write actually any property, like for example px such that x has taken calculus course. All right, or p of x, y, I can have more than one variable. All right, I can have more than one variable, as much as variable you want, but each variable should have a property. All right, p of x and y such that or p predicate of x, y, b, or we can say p of x, y represent x plus y greater than 10. Okay, so now it looks like a function, right? So because we are using this parenthesis and we are taking a variable inside the parenthesis, so these predicates are actually also known as a propositional function. So still it's not actually a proposition or a statement, right? So we are saying that that's a propositional function or predicate such that p of x such that x greater than 10. Now it will become a proposition if x has a value. Okay, so it will become a proposition if we know a value for the x. For example, like for this proposition, okay, say for this proposition, let's see, we can evaluate the value of 12 or 3. Okay, say now we have this proposition, the first proposition, and now we can evaluate whether this predicate logic is true for x equals to 12 or x equals to 3. So if x equals to 12, you can see that 12 greater than 10, so that means this predicate is true. Okay, so this propositional function becomes a proposition when x has a explicit value. Okay, so p12 is true. Now p3, we can see that 3 greater than 10, which is false. So p of 3 is a false. All right, now we can evaluate this statement. I mean, now it will become a statement, okay, when the variable has a explicit value. Okay, so a statements involving a variable like such as x less than 2 or x plus y is equals to z are often like their mathematical assertion in computer program. Okay, so these statements are neither true or false. All right, so we say that they are not a valid statement. Okay, now this statement x is less than 2 has two parts. So the first part is the variable. Okay, so the first part is the variable which is the subject of the statement, and the second part is predicate, which is predicate means is less than 2. Okay, so we have these two part, variable and the property. So that's one is variable and that's one is property. So together this property and variable, it can create a predicate. Okay, now the predicate is here is less than 2 can be denoted as p of x. Okay, where p denotes the predicate and x denotes the variable. So this predicate, where we write it like that, it looks like a function, and we say also it's like a function. It's a propositional function. Okay, so propositional function represents a property about a variable. All right, so propositional function becomes a proposition. When it becomes a proposition, it can have a truth value. So truth value can be true or false. Okay, so it can become a proposition when their variables are each replaced by a value, and this value can be in a specific domain. Okay, domain, or it can be bound by quantifier. We are going to talk about that later. All right. So for example, this statement px is said to be the value of the propositional function p at x. Okay, so we say that this one is a propositional function. All right, p is the function at x. Now let's see the propositional function px, or the predicate denote x greater than 0, or also we write it like that, px such that, okay, x greater than 0, or we also write that px b x greater than 0. So always remember, a predicate or propositional function means it has a variable and it has a property. Okay, so x is the variable and this is the property that the variable is greater than 0. All right, now these things are proposition because we are replacing the variables using a value. Okay, so for example, p minus 3, we can evaluate p minus 3 with either true or false. So let's see, minus 3 is not greater than 0, so p of 3 becomes false. Okay, p of 0, is 0 greater than 0? No, so p of 0 is also false. So what about p of 3? So 3 greater than 0. All right, that's true. So p of 3 becomes true. So often we say that the value will come from a domain, a specific domain. Okay, so we are going to mention a explicit domain. The domain could be a list of integer value, or a list of natural number, or a domain can be all the real numbers. Okay, so often the domain is denoted by u means like the universal domain. So, and we may also give you the some more about the domain, like for example, domain is all the integer value, or domain is all the positive integer. So let's see some more example. Let's see, we have a predicate logic. So predicate logic looks like this: r, x, y, z. So we say that, I mean, a predicate logic means it's a list of variables and a property. Okay, so list of variables can be one variable or it can be more than one variable. So here this predicate logic says that r of xyz such that, or r of xyz be that x plus y equals to z. Okay, so let's find out the truth values. So our first proposition here, we are saying that now we can say that that's a proposition because each of the variables has been replaced by a value, and each of them actually we can actually find a truth value. Okay, we can evaluate that using either true or false. So if r2 minus 1 5, so in that case x is 2, okay, plus minus 1, what is the value? That should be 5. Okay, so here 2 minus 1 becomes 1. Okay, so that's actually false. So that's not equal to z, means that's not equal to 5, so this one's false. So this is a proposition and the truth value is false. Okay, now what about this one? So r3 4 7, so x, y and z. Okay, so we're going to find out x plus y equals to 7, which is same equals to which is same equals to z. Okay, so we found x plus y equals to z, so this one is true. Now what about this one? So we have x, 3 and z. Looks like we're trying to evaluate whether x plus 3 equals to z. Okay, so here actually only we know the value of y. Okay, so still our x plus x and z are variables, so that's actually not a valid proposition or a statement. So that's not valid because we still we cannot evaluate it either true or false. So each of the variable must be replaced by a value. Okay, I mean we have to evaluate it with true or false. If there is one variable we do not have the idea about the value of the variable, that means that's not a valid proposition or statement. So we saw that each of the predicate becomes a proposition or statement. All right, if we replace the variable with a value, and if we can evaluate them either true or false, that means actually we can use them either with some other connectives and we can create some compound statement. Okay, so let's see, we can actually do some more operation with and or operation, or we know some other operation like implication, not, right? So let's see some more example. Let's see, we have a p predicate p of x such that x greater than 0. So what should be the value of p of 3 and p of minus 1? So p of 3 is 1. Okay, 3 greater than 0. P of minus 1 is false. So true and false, uh, sorry, that's actually or, I'm sorry, I'm reading wrong. So p of 3 is true and p of minus 1 is false, and we are doing the or operation here. To true or false, that becomes true. Okay, simple actually. So we're going to have multiple proposition. If we have multiple statement, all right, we can use them with other connectives. So this one is an and statement, so this one is true, this one will be evaluated to false, so true and false will become false. So this one is an implication, so p of 3, that is true, p of minus 1 is false, true implies false becomes false. So now p of 3 implies not p of minus 1, so p of minus 1 is actually false, but with not it will become true. So true implies true becomes true. Okay. Now if we write an expression with variables, they will not be proposition, and therefore there will not be any truth value. We saw one example here. Okay, and here is another example. Like if we are trying to write something like that, p of 3 and p of y. So we know the value of this, but we do not know the value of this statement. Okay, so that's not valid. Same as here, p of x implies p of y. We do not know about the value of x and y, so they are not valid. Okay.